Hello and welcome to another video from oorail. In this video we're going to show you how to reasonably safely connect both DC and DCC controllers to the same track. Basically what we're going to do is we're going to use this double pole, double throw switch so that you can switch it down for DCC and switch it up for DC. And so when it's in the up position, basically the power to the track will be sent from the DC controller, and then when it's down like that, the power from the track will be coming from the DCC controller. And so what this allows you to do is basically have a nice little toggle switch so that you can toggle one of your loops or an end-to-end layout with a single switch and flick between DC and DCC. Now I'm going to get into that in just a minute, but I want to show you something else first. So a few months back, I came across a guy selling some Hammant and Morgan stuff in Canada. It's this H&M. Now H&M are an old company that used to make power controllers. I don't think they're still around. I think Hornby bought them out. But basically they made some really cool power controllers, and anyone who's older than me will probably recognize the clunky control here. Always gives you really good tactile feedback, so kind of always like these particular controllers. Now my dad had a couple of the duets, and so I grew up using these kind of controllers, so it was kind of cool to get a couple of these in. So I did get, I think I got 2 duets, a couple of safety minors and a few others, but I also came across this one, which is a Power Master. And the difference with the Power Master is that it has these on-off switches here to allow you to select a particular circuit, and then you can control that circuit from the controller here. So this stuff is pretty old. However, I was really lucky in that these guys in Canada had either bought a liquidation lot or they were liquidating at some old model shops. And these were old stock that had never been opened, never been powered up. They were brand new, and they've just been sitting for decades in somebody's storeroom. And so I got all these, and they're, with the exception of one of the 10, 15 controllers that I got, all of them were brand new. And some of them even had the original instructions and stuff. And I also got some point motors too, so we'll be showing you some of that stuff later on. Now these are the export models, you can see there the controller looks pretty new, but yeah, they're the export model, so they're the 110 volt, so they didn't need any kind of conversion to run here in the States. I'm not sure if some of them had export model stamped on them. This one just has the 120 volt stamped on it there, and it's pretty cool. So what I'm going to be using this for is I'm going to wire up the some of the sidings independently. So most of the sidings are already connected with insulfrog points. So each of the kind of spurs off of the points are already isolated, and then they're also connected with isolated fish plates, a couple of inches down, maybe a loco length or so, past the points themselves. So that allows me to basically independently wire some of the sidings there, and so I can control the sidings independently while trains are running around the main loop. So I'll just give you a quick look. This thing is pretty substantial. At the connections at the back, you have a common, and then each of these goes to your independently wired circuit. So we've got 1, 2, 3, 4, 5, 6, and they correspond to the 1, 2, 3, 4, 5, 6 here on the front. You got your typical half wave, full wave, and then there's a boost button here that can provide full voltage, full current. And I'm guessing if you want to do more than one circuit, you'd hold that in and maybe flick 2 of them down. The instructions for these were pretty minimal, so I'll have to experiment a little bit. But you can see here, it's made in England to some particular British standard by Hammant and Morgan, and you can see here it's got a total output of 2.5 amps, so it should be able to handle all the triangle locos as well. Alright, So I just wanted to show you that. So I'm going to move this out of the way and I'll start to explain how the circuit is set up. So I'm going to explain this as simply as I can. If you have any questions, just put them in the comments below. First thing I'm going to do though is explain the switch. So the switch has a on, a off in the center, and then on again on the bottom. And basically this switch is two of these connected together. So it's basically 1 and 2. So horizontally, these are not connected ever. Vertically, everything is connected in common with the center one. So when the switch is thrown up, it's the reverse. The bottom two are connected. When it's down, the top two are connected. So this center row is the common, and then depending on which way the switch is thrown, it connects the other two to it. So what we're going to do is, like I said, we want it so that when it's thrown down, the DCC is on. When it's thrown up, the DC is on. So with that in mind, we're going to wire, remember it's reversed, so we're going to wire the two wires that come from the DCC controller into these top two, the two wires that go to the track in the center, and the two wires that go to the DC controller to the bottom. So the two wires going to the DCC controller in the top, the two wires to the track in the center, and the two wires to the DC controller on the bottom. So this is perfectly fine. You can run the two, switch up for DC, switch down for DCC, and in the center there's no power going to it at all. That said, this is a mechanical switch and there's a potential risk for this thing to fail. It might connect. These are, I think, physically isolated from each other, so I don't think you're going to get any kind of cross connection. But there's a possibility you could connect all three together for some reason. So either this side or that side could all be connected, and that could do a fair amount of damage if you have both your DC and your DCC controller on at the same time. Could do some damage. So what we're going to do is we're going to put a second double pole, double throw switch in between the DC controller and the switch. Now you could do it for both the DCC and the DC, but since I'm the only one that really uses the layout, and at least I'll be the only one using this part of the layout, I don't see the real need for it. So I'm just going to do it on the DC side. And so what I'm going to do is I'm going to wire the power controller to the center here of this switch. So we're going to have the two wires that come from the DC controller going to the center. We're going to have two wires that go to this particular LED circuit on the bottom, and then the two wires going to the switch on the top. And so the idea is that when I switch the switch down, alright, power is going to the track and that LED doesn't come on. If I switch it the other way, if I turn on the power controller, the DC power controller, this LED will illuminate and there'll be no power going to the track. And so on my control panel, I'm going to have this thing here, that's going to be our DC master switch. We're going to have this, which is going to be our DCC DC switch. And then in the center, or maybe on this side here, I'm going to have this LED with a little LED saying DC off indicator. So when the DC off indicator is on, I know the DC is off. When the DC off indicator is off, then I know there's a potential the DC is powered to this particular track. Alright, now the coolest thing with this, by the way, is these things are pretty cheap. They're like $1, maybe $1.50, if that. And what you can do is you can do this for each of your track segments, however you want to do it. So you don't just have to do it for one. You can physically switch a couple of different loops and come up with some pretty complicated track diagrams and circuitry if you want to. So I'm going to show you just the basics, and then you're limited only by your imagination and what you're willing to wire up. So I'm going to walk you through this illumination circuit, which would be wired, like I said, to one section of the switch, and that's basically it. So what I'm doing the rest of this video is explaining this circuit, and then I'm going to go and solder it all up, and then I'll show you how to install it over the layout, and I'll show you it working. So just give me a minute. Okay, so I'm going to go and explain the basic LED circuit here. We have the two wires coming from our Bachmann DC controller, and then we have a fairly simple circuit. We've got two resistors. These are two 570 ohm resistors, and we have a basic red LED and a couple of wires, and that's it. So you have one of the wires coming from the controller, and it's going into this white wire, and that white wire is connected to one of the legs on this resistor, and then the other leg of this resistor, it's on a different row, it's connected to the other leg of resistor number 2, and this is called being wired in series. You're just kind of plugged in one after the other, and then the other leg of the resistor is plugged into the long leg of the LED, and then the short leg of the LED is bridged with this orange wire back into the return into the controller. So, like I said, you have the two red wires that are going to the controller, and you have one side going to one resistor, the resistor connected to the next resistor, that resistor connected to the long leg of the LED, and then the short leg of the LED is connected back into the power supply. And so if I turn the power supply on here, you will see that the LED comes on, and as I adjust the power up and the power down, the illumination goes up and down. Now the two resistors are there to protect the LED, so if I make a silly mistake and I crank this thing all the way up to 80% or something like that, it's not going to burn out the LED. It's not getting hot. It's pretty bright, but it's not getting hot. And unless you're running something like a 16 volt controller, you should be able to run this at 100% without the LED getting too hot. Here, it's not getting hot at all. And that's just there to protect the LED. You don't want to have to keep replacing the LED if you accidentally do that, especially if it's in a control panel. Alright, so if for some reason the LED doesn't come on, so if I turn the LED on, if I change the polarity of the controller, now what's happened is the positive and negative side have flipped, and so the circuit doesn't work anymore. So I just need to flick it back, and the LED comes on. Now, you may have noticed in the video earlier, I said that when the LED isn't on, then I can assume that there's power going to the track. So if for some reason the polarity is switched, that LED is still going to be off. So I'm going to err in caution rather than think, oh, the LED is not on, so the power is not on to the controller or to the track. So to wire this into the switch circuit is pretty simple. Instead of taking these two wires from the controller, the two wires will be coming from the switch. So the top two wires here, one wire will be coming in here, and the other wire will be coming in here. Now, if you're like me and you do directional running, so you have left hand running because it's a British layout, then you can figure out which polarity is left hand running for your controller, and then you can wire it up so that the positive and negative are wired the correct way so that the polarity of your controller matches the LED and so on. And then obviously your power from your controller, so these two wires here, would be wired in to these two in the center, and then these two last wires here would be wired in to the other switch. And it's as simple as that. And so that way you can switch this on, and the light comes on, and you know that the circuit is protected. Then you can turn off the DC controller and use the DCC. And then if you want to switch back to the DCC or switch back to the DC controller, you can turn the controller on, watch the LED come on, and then flick the switch, and you're good to go. Alright, so what I'm going to do next is basically solder this all up, and I'll show you it running on the layout. Now there's one other thing with these, before I do that, there's one other thing with these toggle switches, and they have a little bolt here that you can remove, and then what you do is you basically size up that thread that's right there. You can see it's that thread that's right there. Figure out what kind of size that is. They come in different sizes, so it'll give you an idea of what size of a kind of a hole to drill in your control panel, especially if you have a wooden control panel. So you drill the hole, pop this switch in from behind, and then use that bolt there to secure it to your panel, and likewise with the other switch. And that way you can make it look nice, and so on. Alright, so I'm going to go solder this up, and then we'll show it to you working on the layout. So we're back over at the layout, and right now we have a Deltic running on the layout, and using the wireless Dynamis controller. I need to put the base station somewhere a little higher, but right now the base station is kind of over here next to the DC controller. We have the wire coming up from the H&M into this terminal block, and then some wires go back into this DC on-off switch, and then they go into the other switch that we mentioned before. There's an LED embedded in the panel there, and I'll explain how I did that in just a second. And then there's wires right here that are going to a terminal block that go into the track. And it sounds like I just had a coach come undone, so I just hit stop, and then we'll just resume. Yeah, it's all good. And so yeah, so sorry about that. Some trains running. So this here is the line going to the Dynamis base station, and like I said, this is the one coming from the H&M. It's pretty easy, and we'll show it to you in action. So I'm going to zoom in first of all, so you can take a quicker, kind of closer look at the thing. So like I said, this is the terminal block that has H&M coming into it. I have a little LED, it's our LED warning light, and then this is the on-off switch, so I can actually, with the Dynamis running, show you. That's the DC controller that I've just powered up, and you can hear the DCC is still running without any problems, and my little warning light has popped up here to let me know that there's no DC going to the actual track. And then here we have our DCC and DC switch. I'll do some sort of nice paneling with that, but for now it's kind of been knocked up and works pretty okay. So how did I make this? This is just like a dollar piece of wood that I've cut in half. It's not very thick. I'd say it's probably maybe 3-4 millimeters thick. I bored 2 holes in it here for the switches. I also did the same thing, about 1 millimeter in on the back for this, and then I drilled through it with a smaller drill bit, and that sort of created a recess for the LED, and then I basically just stuck it all in with electrical tape. I mounted this to the underside of the baseboard using a couple of wood screws, and I tied it up like you can see with some electrical tape. So what I'm going to do is I'm going to zoom back out, and I'm just going to give you a quick look at the thing. You have to excuse my camera work here, it's probably going to shake a little bit. So here you can see we have the Dynamis controller. It's going up, I have to clean these wires, but it's going into this terminal block right here. Looks like I've lost the coach again. I'll have to fix that set of points, I think. But yeah, so you have the Dynamis block is going in there, and then those wires run back into this switch, and they're on the bottom part of the switch. Remember what I said? The bottom part of the switch does the upper part, and then the top part of the switch does the bottom part. And then the DC, which is wired on the top part, it goes into this particular switch here. And then the LED circuit is wired onto the other side, so this one actually switches left and right, and this one switches up and down. And then we have the H&M, which is going into this, and then going in here. And you can see here it's going in there and then down into this box of tricks right here. Alright, so I'm going to move the camera over to the layout so you can see the DCC locomotives going around, and then I will switch trains to this particular one. I think Dave and a few other folks wanted to see that on the layout, so I'm going to run that. And I'll just give you a quick, this won't be pretty, but you can sort of see back there's all the wiring and whatnot for it. But it creates this kind of nice kind of hang down panel above the controllers, so it's easy enough to use. Alright, so let me go move the camera and let you guys see some trains on the layout. Okay, so you've seen it run around the layout a little bit, so now I want to switch from, say, DCC to DC. So I'm going to go and take the DC locomotive off the track here. Alright, so the DC locomotive's been set aside. I'm going to fix the... For some reason these Hornby weathered LMS coaches don't seem to, or real marine coaches don't seem to like the coupling on that Deltic. I'll have to take a closer look at that. But here we have Lady Patricia. This is a much older Hornby locomotive. And right now DC controller is sitting on there, or DCC controller is sitting on there. So what we're going to do is move the camera down here, and I'm going to turn the Dynamis controller off. And then what we're going to do is we're going to switch it from DCC to off to DC, and then I'm going to check. You can see here. I move that, and you can see my lights on because my DC is off, but I'm switched to DC. So I'm going to come back down here and switch that off, and then I'm going to switch that to DC on. You can still see the Dynamis hasn't blown up. And then if I move the camera just about there, we should hopefully have the DC controller powering the thing. And it's no trick. There's the H&M on, powering the layout. And you can hear it running. I can flick that switch, and you can hear it's gone to complete stop. I can also flick this into the center, and it stops. Alright, so it's thumbs up, it's looking good. So I'm going to go let you guys take a look at Lady Patricia on the layout, and perhaps to some music. Okay, so there you have it. It's took a little bit of effort, but hour or two this evening to wire this up and get all the bits cut together and kind of clean up the wiring and stuff. But all in all, it's a nice little project. I can now switch easily between DC and DCC. Just takes a couple of seconds to do it. Just put the loco on, hit the switch, we're good to go. We've got the safety warning light in there, as well as the DC on and off, just to be extra careful. And it's looking good. So what we're going to do is we're going to take this concept and expand it throughout the layout. For example, on one of the loops, we're going to divide it up into blocks. So we'll probably have a number of these switches to enable you to switch on and off the blocks and so on. So that's it, I think, for now. So I hope you enjoyed the video, and you got a sneak peek of what might be coming up in the next video. So until next time.